Okay, if you have not looked at the Desmos slider that is posted to Canvas, please do that first and make sure that you've played around with that slider and have responded to these questions, because the rest of this lesson is either confirming what you saw with the Desmos slider and confirming and affirming that, what you saw is what you thought is correct, or kind of changing what maybe you assume to correct that. So if you haven't done that, please go back to Canvas. There's a graph to click on that will take you right to the link, okay? All right, so after you have done that, hopefully you are seeing those horizontal stretches and compressions. So a little bit different than what we saw going vertically. So here, if f is the function and k is a positive constant, then the graph of y equals f of kx is a transformation horizontally compressed by a factor of 1 over k if k is greater than 1. And on the other hand, we are going to have that be horizontally stretched by a factor of 1 over k if k is between 0 and 1. So this is kind of counterintuitive. So for instance, if you had y equals f of 2x, you might think that that is a stretch because of that 2, but remember, those inside changes are counterintuitive. So that's actually a compression by a factor. In this case, it would be 1 over k, or 1/2. If we had something like y equals f of 1/2 x, that is actually going to be a stretch, again by a factor of 1 over k. Basically, you're taking the reciprocal of that to get the amount that you're stretching. So that would be a stretch horizontally of 2. If k is less than 0, so for instance, y equals f of negative kx, then what's happening is we are taking that horizontal stretch or compression and we are taking a reflection over the y-axis. Remember that the negative on the inside reflects over the y-axis, okay? All right, so if you look at this example, it says that the red graph is the graph of g of x. So let's label that. This is our g. Ooh, that would be kind of confusing if I do. Where's my eraser? I don't know how to erase, sorry. Oh, there we go. Okay, sorry about that. So this is g of x, and then the blue graph is h of x. Okay, so it says that f of x equals x squared. So let's go ahead and graph that one. So again, that's just our basic parabola. So it has a point 0, 0, 1, 1. Oh, that's not 1. 0, 0, 1, 1 is actually here. Then 2, 4. So this is our f of x equals x squared. Our job is to write g of x and h of x in terms of f, okay? In terms of f. So we'll talk about what that means. Basically what that means is we are going to just use f in the function, and using that f we have to kind of describe the transformations. So let's look at g of x first compared to f of x and see what's happening. Okay, so I want us to focus primarily on these y values when y is 4. So horizontally, we're changing the x values. So in our original function f of x, this x value is 2. So when we go to g of x, now at that y value, what is the x value? We do have to approximate a little bit. Let's say that that's 1/2. Okay? So what's happening is that we are decreasing by a factor of 4. So g of x is going to be equal to f of 4x. Since I'm decreasing or compressing by a factor of 4, that's an inside change. If I look at h of x, so again from that y value of 4, I look over here. So that x value has changed from 2 to 4. So I have stretched by a factor of 2. So h of x is equal to f of 1/2 x. That 1/2 means that we are stretching horizontally by a factor of 2. And that inside change of 4 means I'm compressing by horizontally by a factor of 4. Okay. Okay. Last example, I'm going to have you guys on your own do the graphs, but together we'll talk through what each of these transformations are doing to our original function. F of x equals absolute value of x. If you are unsure what that original function looks like, graph it on your calculator. Okay, it's going to be your absolute value graph, or that V shape. Okay. So I'm going to have you do all the graphs, but we can talk through what each of these transformations is doing. So some of these we're pretty familiar with. So for example, negative on the outside, this is our reflection over the x-axis. On the second one, f of x plus 3, this is a shift to the left 3 units. For part C, f of x minus 4, this is a shift down 4 units. And then D and E, this is where we're getting into our compressions and our stretches. The 5 on the outside is a vertical stretch. So we're changing Y values. Vertical stretch of a factor of 5. And this is the one that's kind of confusing. Those horizontal, those are counterintuitive. Okay, so f of 1 over 4x, this is a horizontal stretch, so x values of 4. So what I want you guys to do, and it would probably be good if you did it in different colors, so graph your original function, and then in a different color, graph each of those transformations.